the last example that we had tried yesterday was working with link, and we had, I had done a few examples with you all, but I had not completed the topic for link, and I'd asked you to try that in the lab. So hopefully, it worked fine and no problems, and there are no doubts regarding that. So let's take it forward from there. We'll continue from that point on. Okay, let me share my screen. So this is what we had done last. Right. So we done a join between the two and stopped at that. Okay. So let's take a few more examples with this. And one of the statements that we are trying out here, I'm actually continuing yesterday's example only because let me complete that section there. I'm not gone for a new project. So I've given a group something by something. So from EMP and LSCMP, group the employees by employee.department number. Now, when you write a group by, what this does for you is something like this. If you look at the records that we have, these are the record values that we have, sample data. So it's going to group it on the basis of department number. Now this creates for you the following output. Firstly, the department number itself. And secondly, all the employees who are in that department number, it creates a collection of such employees. Right? So group number 10 or department number 10 has a group which has 10 and a collection of such employees. Similarly, if you look at this, these three employees are in department number 20. So 20, comma, these three employees. Similarly, next to employees in 30. So comma, these three employees. And 40, comma, the last employee is a single employee in here. So this is what is actually creating out here. Right? Now, what does this resemble? What does it look like? Something and something. What is this actually? Does it remind you of something else? Yes. Does it remind you of something? Where I'm saying 10 and something, 20 and something, 30 and something, 40 and something.
So key value pair.
Right. So it's actually like a key value pair, wherein the key will be the department number and the value would be the employees that belong to that department number. So that's what is actually creating for you. Now, this is one key value pair. This here, the highlighted section is one key value pair. And this is the second key value pair, the third key value pair, and the fourth key value pair. So it's actually creating an enumeration of key value pairs. And each key value pair here is an I grouping. So if you look at the statement, I'll go back to what I was asking you yesterday. Like if you looked at the code out here, yesterday we said select EMP. So what is EMPS now? yesterday's code. If EMP was an employee, what was EMPS?
INumerable
INumerable of employees. So I have asked this question multiple times yesterday. Hopefully you're clear about that. Now, applying the same concept, I'm saying that each of this is a group. Each of these is a group consists of what? The key and the value. So see what this is returning. EMPS now is an INumerable of a I grouping. An INumerable of a I grouping. And each I grouping is consisting of what? First is
integer.
integer. This is the key, and this integer will contain what? Will contain what?
Department
number.
Department number. And the second one is employee. So actually it's not showing you that, but internally it's creating a collection of employees. I grouping of int comma employee indicates that the key is a department number, which is an int, and the value is a group of employees. So that's what it's creating for you. And you've got an INumerable of such things. So the way in which I'm writing the loop would change slightly. When I loop through this, if EMPS is an INumerable of a I grouping, that makes EMP as an I grouping of int comma employee. And this I grouping has a property called key. It has only one property. It has just one property called key. And the key will give you the department number. And this itself can be iterated through. Right? This EMP is a grouping of employees. So it's again a collection. And if EMP is a grouping of employees and you're iterating through that, what does that make E now in this case? If EMP is a group of employees, what does that make E?
Key.
Employee.
E is one employee.
Employee.
Right? So if you look at E dot would give you all the properties of the employee. Are we clear on this? So look at this. E was an employee. EMP, of course, was a I grouping of int comma employee. So now I'm able to, display the values in this way. I have overridden employee. So let me just print E out here. And let's try printing this. So this is how I would actually get the values. I'm getting the key and then the value. This is how it would actually look. Okay, so that's a group by. Okay. I'm making a small variation to this. Right, so in the next example, I'm making a small variation to this. And the only variation, the only change in my code here in the next example is that I have given the group a name. I've given the group a name. So for example, here, I didn't have a name for the group. But in this example, what have I done? The only difference is what? Given the group a name. And then I'm saying select the whole group. The code that I've written is identical. There is no change in the output. It works exactly the same way. The difference being that this one has a name for the group. Right? Same output, no difference whatsoever. Now, when you give the group a name, see what I can do with this now. See what I can do with this. So look at the next example. I've given the group a name. And if you can see what's happening here, what am I selecting here? Firstly, select new so-and-so, that's an anonymous type. So select new group one. So select the whole group one in any case, right? And what is it also allowing you to do? What am I giving here? What are these? If you look at group one dot, what are all of these? What are all of these? Can you identify what these are?
Methods of system.collection.
Yeah, but aggregate functions, that was the answer I was looking out for. Okay, so you can actually give the aggregate functions that you want for a particular group. So I'm actually picking up the count, or I'm picking up the max, or I'm picking up the min, right? I'm picking up these values out here. And while displaying these, I can now display these values. So I can display, first thing is what is being selected here is what? What is being selected here? What are we selecting here?
Group.
No.
Anonymous type.
Anonymous type, which contains the group and other properties. So what is this now? A collection of IEnumerable of an anonymous type. Which contains what? Which contains what? What is the thing it contains? First thing it contains is a grouping. And it also contains properties like count, min, and max. All right. So this is what I have taken. See, in the earlier example, what was I doing? I was picking up the whole group. But now I'm picking up an anonymous type which contains the whole group and other properties. And I can actually given these values out here. So m.count, m.min, m.max. And if I wanted to print, let's say the department number, let's say I wanted the department number, m.group1 is the entire group. m.group1 is the entire group, right? And then from the group one, you have a property called key, which is giving you the employee number out there. So this is what you could do for the, not employee number, department number. Are we clear on this, everybody? The other part of it is the same, go through the employees in the group and display the employee details. So this is what you could also do. Put in aggregate functions if you're using a group. So within the group, you're getting the first part here is what? What's the first property here? First one here is the department number, group.key. And then you have the count. You have the max or the min, sorry, the min and the max. And then the actual values in the group. So this is what you are actually getting here. Are we clear on this, everybody? So try these out in the lab again. I didn't do them yesterday. We were running out of time. It would have taken another 10-15 minutes more to get this to work. So we didn't do this yesterday. All right. Okay, so now what we've done here is we have created, I've just copy pasted that code and let me sort of eliminate the functions that I don't want. So I just kept the same structure as earlier. And instead of writing code in this way, using a link query, we're going to use an alternate syntax for writing a link statement, a link query. So what is this alternate syntax? What are we going to do? So we're going to use a combination of this. First thing is we're going to say LST employee dot, and this LST employee dot has a lot of these extension methods given out here. if you look at these, there are a lot of these extension methods given out here. Do you see all of these extension methods? Okay, all of them with the down arrow. Now, where have they written the extension method for? They have written the extension method for IEnumerable. So there is already an extension method defined for IEnumerable, which will be present in system.link namespace. So in the system.link namespace, I'm saying that they have defined extension methods for IEnumerable. Now, what would happen if you define an extension method for an interface?
All the classes that are implementing their interface will also get that method.
Correct. Right? So all classes that implement that interface now also have those methods. And this is what we are going to try out here. Now, what is LST employee, LST department? These are actually list of employee, list of departments, and they also implement IEnumerable. So these would also have all these extension methods that have been defined for IEnumerable. When you're writing a link query, you can write a link query on anything that implements IEnumerable. We said that yesterday, right? So which means now all your link queries will have these extension methods available to you. So we're going to see an alternate syntax. Instead of writing this, we will try out an extension method. So what if I had to do this only? Let me just comment out this for a moment. And I had to say LST employee dot. One of the methods that you have there is select. So two things. First thing is it's an extension method. Look at the down arrow there. It's an extension method. Second thing, angle brackets. Angle brackets meaning what? Here it's a generic type. It's using a generic type. Okay. So if you're using, let's say, LSTMP, which is a list of employee, what we'll have to pass to this select would be an employee. It's using a generic type. So if you're using a list of employees, what we have to pass to select would be an employee out here. So let's see what it takes. What does it take? Look at dot select. What is it? What is it taking as a parameter here? Look at this. These are the parameters. This is the actual function. This here is the actual function. Here, dot select. And these are the parameters of the functions. What is the first parameter it takes?
Func employee.
Func of employee, comma T result. So this select expects a function, right? What is func? Func is a delegate. Delegate expects a function. So this select expects a function which has an employee as a parameter and can return anything from there. Again, I'll repeat. Look at select. What does it take here as a parameter? Func of employee, comma T result. So this select expects a function which has an employee as a parameter and return type can be anything. Return type is not given. It's saying T result. Are we getting this? So let me do this the long way. Let me do this absolutely the long way. And let me write a function here. Called get employees, which takes an employee as a parameter. Right? And return type can be what? Return type can be anything. So in the first example, I'm going to return an employee. I'm going to return an employee. Okay. All right. So whatever employee I receive, I'm returning the same employee. Whatever employee I receive, I'm returning the same employee. And here now I could say LST employee dot select. So instead of writing in this way, I could say where ems is equal to LST employee dot select. And what is the name of the function that we're giving out here? Name of the function was get.
Get employees.
Get employees.
All right. Now, how would this work? What would happen? When you say LST employee dot select, LST employee is your collection. It contains all the employees. Supposing it contains, how many records do I have? I think I have 8 records. I have 8 records here. So if I have these 8 records, then it will call this function get employees. It will call this function 8 times. Why 8 times? Because I've got 8 records. Number of records, as many records that I have, those many times it will go and call this function. All right. Now, first time it calls the function. What does the function expect as the parameter?
Employee class object.
Employee object. So first time it calls the function, it will pass the first object from here to the employee. So what will it do now? It will take this one. The LSC employee contains 8 employees. So it will pick up the first employee and pass it here. Now what am I returning from the function? What am I returning from the function currently?
Same employee
Object.
Same object.
Return
Same
the same
Employee
object. So whatever I'm returning from the function will go into the output. So this is my input to the get employees, and this is the output from get employees. And whatever the output is going to be added and put and returned into EMPs. So how many times is get employees going to be called? 8 times. First time it's picking up Vikram's record and returning that Vikram's record into the output. Second time it's picking up Vikas's record and returning Vikas's record into the output. Third time Abhijit's record and returning Abhijit's record into the output. Continuing further. 8 times it will keep doing this. 8 times it will keep doing this. So what is EMPS going to be a collection of? EMPS is going to be a collection of what?
employee.
Of employees. So EMPS here again is returning an IEnumerable of employee. Whatever this function returns, that is what EMPS will contain, a collection of that. Are we clear on this, everybody? Yes? Understood?
Yes, sir.
Yes.
So if I run this loop now, again, I mean, if you know the answer to the question, then it becomes very easy to write down code. If EMPS is a IEnumerable of employee, then item is a
IEnumerable of employees.
no rallying.
Employee.
EMPS is an
Employee.
IEnumerable of employee.
One object.
So what is item then? Item is
Object of
one employee, one object of that collection. Are you clear on this? This is the same answers as yesterday. If you all are writing that code I told you, you'll have to ask yourself the same question. If you know the answer to the question, your link query becomes easy. Somebody's mic is on. If you're not answering, can you please turn it off?
Abhiraj.
All right. Any questions about this one? Any questions about this one?
So
Yes.
how is it calling the get employees on that particular the way you said it, that it is calling on particular employee, right? in order.
It's like a loop. It's like this statement. It's like this statement. This here
Okay,
is a
got it.
replacement of this statement.
Yes, got it.
I don't want to show you the debug mode right now because there is one more very important concept at play out here. So I don't want to confuse you with that concept. Otherwise, I would have shown you the debug mode. I would have shown you how it's getting called. But if I show you the debug mode, I have to then explain one more concept. So I'm keeping it simple right now. Let's understand one concept at a time. Okay. A little later, I will explain one more concept and then I'll show you the debug. But when you're in the lab, you can actually put into debug mode and see how it works. Okay. All right. Now, what did this function return? Get employees. What did this return?
Object of employee.
Employee. Instead of an employee, remember the select said that you can return anything. Select didn't say that you have to return an employee. When you said dot select, what did this ask you for? It said the function can return T result. T result is anything. So instead of returning an employee, I'm going to return a string. And instead of saying return O, I'm going to say return O dot name. What is the change that I made out here? Instead of returning the entire O object, what am I returning?
Just name of that employee.
So what is this statement similar to? What is the statement similar to? In get employees to, what will it be similar to?
Select emp dot name.
Correct. So this will be select. Instead of just saying emp, this will be like writing select emp dot name. Sorry, dot, not the greater than. That's what we're doing. And how would, what would the code that I'm writing now be? Let's say ems2 is equal to get employees 2. This function returns this. Now think an answer. It receives an employee but returns a string. So what is EMPS2 going to contain? What is EMPS2 going to contain?
Enumerable of string.
Very good. Enumerable of string. So if I said EMPS2 out here, if I give what does that make item? What does that make item?
A single name.
Name.
Not
One
data type of item I'm asking.
Strings.
one string.
String. Name is not a data type, no? You're right. I know you know the answer, but give me the answer to my question. What is item? Item is actually a string. So look at this. And yes, that string contains a name. So what you're saying is right. But that is not the answer to my question. So what can we return from in this method here? We can return anything that we want. Are we clear on this, everybody? Okay. Can we write this method? Can we write this method as an anonymous method? Can we write it as an anonymous method? What would you do here? Instead of this, can we write it as an anonymous method? Yes?
Yes. Yes. Yes.
So give me the syntax. All that you do is what? Sorry. All that you'll do here is what? Copy paste the method and replace the method with the keyword
Delegate.
delegate. And this becomes an anonymous method. Same thing I did. Nothing different. Okay. Instead of an anonymous method, can we do the same thing as a lambda? Can we do the same thing as a lambda?
Yes.
Help me. Help me. Help me with the lambda. Yes. What does this select expect? What does it expect? It expects a function that takes what as a parameter? What is the
Employee
parameter?
object.
Employee.
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 And return type can be what?
String.
Return type can be
String.
Anything.
no, can
Means anything.
in this example string. Okay. In this example string, but otherwise the return type can be anything,
Anything.
right? That is what it expects. So one parameter, whatever, E, take E as a parameter and return what? If you want to return a string, what will you do? Return E dot
Name.
name.
D dot.
That is what that function is doing. Supposing you have to return the whole object, then what will you return? Take E as a parameter and return what? Return E.
only.
So what is this and what is this like? What is this lambda like?
Select EMP.
Like the
Get employee.
get employees. What is this one like? This one is like get employees 2, which returned a string. What if I wanted multiple columns? Multiple columns. Multiple columns, yes.
So E dot name, E dot type. No.
What are you
Okay,
missing?
so new object
Object
anonymous
means
objection is like
anonymous class.
You-
Initializer.
Of whatever. E dot employee number, comma. E dot whatever name, whatever other values that you want. Are we clear on this? Aren't these the 3 basic things that we said yesterday? What are the 3 things that you can return? First is you can return the whole object. You can return the whole object. Or you can return what?
Single property.
Single property from there. Or you can return what? If you're returning more than one property, then you'll have to create an anonymous type and given all the properties there. So these are the 3 variations to this. Are we clear on this, everybody? Can we write a function? Can we write a function where we are returning more than one property? Can we write a function when we are returning more than one property? Can we write this function where we are returning more than one property, more than one data type? Yes, no?
sir, we will have to make it as anonymous type. No?
You cannot have an anonymous type. You'll have to give
As a
the name,
return.
na?
Okay, correct.
We have to give the name, na?
Mhm.
What are you returning? Anonymous type doesn't have a name.
Correct.
So you cannot return an anonymous type from there. So the only way of returning an anonymous type here would be using a lambda. So there's a reason behind why they have done everything. Why did they introduce var? Why did they introduce var? Because you were in your link query, you are going to be having a anonymous type. An anonymous type cannot have a name. So that's why they called it var. Why did they have a lambda? For taking care of this situation. Why did they have an anonymous type? For taking care of the earlier situation that we talked about. So all the language features that we saw earlier are required for link. Extension methods. Why did they bring extension methods? Because they wanted to support link. All those language features are all answer was all what? Why did they bring that language feature in? Answer is link. So link has all these concepts. Have we understood these statements, everybody? These 3 different statements. So this is the alternate syntax. Instead of writing the longer link query, you can use the lambda based syntax. Are we clear on this? What does it? Can I also write my own method here? Can I also write my own method here?
Yes.
Yes.
But what is the limitation with the method? Where does it not work?
Cannot return multiple data types.
Correct. If you do return an anonymous type, then there is a problem out there. So there, the only syntax available is the lambda. which is why rather than write your own functions, the preferred option is to write lambdas. Any questions regarding the lambdas that we have written? Because I'm going to go now a little quicker with this. If you have understood this, then I'll go a little quicker. And then we'll see how we can write all the code that we wrote yesterday for link. Let's see how we can write it today using lambdas. Clear on this? Easy? Any questions? Let me know. Okay. So let me remove the unnecessary code that is just making it look more big and complex. Okay. So these are the three things that we did in the previous example. Now, we tried out other options with this after trying select. So I'll just go in the same order that we tried it out yesterday. The next thing that we tried out, of course, was after trying out the selects. Sorry, looking the wrong one. After trying out the selects, the next one that we tried out was the where. So if you have to write a where, all right, if you have to write a where, how do you write down the where? So I'm trying to put in the code for this. You will find that where EMPS is equal to LSD employee dot, just like you have a dot select, you also have a dot where. So you'll find that these are whatever statements that you've been using earlier. There is an equivalent method available out here which allows you to pass in that. So dot where. What does where take as a parameter? Help me identify that. What does it take as a parameter?
Of employee.
It takes a func of employee comma bool. Employee comma bool. So it says it will take a employee as a parameter and return a boolean. They could actually use a predicate out here, but they're using a func of employee comma boolean. Right? Remember predicate?
Yes, sir.
Yes, sir.
So that's what I'm saying, that instead of taking a func of employee comma boolean, they could have actually said predicate of employee. They could have done that, but they have not used that. So func of employee comma boolean requires a function that takes an employee as a parameter and returns a boolean expression, and the boolean expression will give you a true or a false. So help me with this. So it takes an employee as a parameter and returns a boolean condition. The boolean condition is given out here. What will this condition, not emp dot, but e dot, what will this condition evaluate to? E dot basic greater than 10,000. What will this evaluate to? Either true or false. Now this is going to be called for all the employees one by one. Again, just like we did for select, where it will run it for all the employees, it will run this for all the employees. And if it returns true, then that employee would be added into the output. And if it returns false, then that employee will not be added into the output. Okay. So individually, each employee is checked. And if the condition is true for that employee, it returns that employee into the output. It's added into the output. And if it is not true, it is not added. As simple as that. Are you clear on this, everybody?
So,
Yes.
sir, can we also put like dot select after where, as in after ending
Yes.
that?
Yes. We are
Okay.
going to. We are going to. Can we? No, you have to now. We'll make it more complex. Are we clear on this, everybody? So let's try running this loop. This is an exact equivalent of this statement. And I hope there's only one main. Right. So from yesterday's record, I think Vikram and Arpan were the two employees whose salary was 10,000. Others all had salaries greater than 10,000. I don't know how many years back I've written that code, but that poor Vikram is on the same salary for so long. I think it's time to increase the salary. Any clear with this statement? Okay, I had that other where clause. This was the other example that I had given you yesterday. In the other where clause, what would only change here would be what? This right-hand side would be the condition that you're putting in there. So whatever is the condition that you're putting in the where clause would be the code that you will put on the right-hand side. That will keep changing. If the condition changes, only this part changes, right? Supposing I wanted basic between 10 and 12,000. So how would I write down this? How do I write down this? And E dot basic less than 12,000. So basically, this here is your condition that you're giving in the where clause. So this only gives me employees with, I think 11,000, 3 or 4 employees are there. So you can try out these, you can try out how this works. Okay, try giving different conditions here. All right. Now, I can, if you look at this, what is this returning? If you look at this, what is this returning? This whole thing is returning what?
Employee object.
Right? This whole thing is returning. It's not an employee object. What is it returning?
INumerable of employee.
INumerable of
INumerable
employee.
of employee object. So it's returning that. Now, if it's returning an INumerable of an employee object, on this thing itself, on this output itself, I can again have a link expression. If I'm getting an INumerable of employees, can I not write some further link query on that? So you'll find that I can actually combine. This is what Kaustubh was asking me. So I could now say dot select, all right? And what, let's say, take employee and return employee. I could do this. Okay. Now, if I do this, take employee and return employee, all right? Let's call this ends2. If I say take employee and return employee, is this the same as the previous query? In the previous query also, what are we doing? We're saying what? Return an employee. So here, if you want to say take employee and return employee, then you need not write the select. Clear? Okay, what if I did it the other way around? What if I said from LST employee, take employee, return employee? What will this return now? What is this first query returning? What is the first query returning?
So all the employees.
All the employees.
Data type. Give me one word. Data type. What is the
Employee.
return?
INumerable of employee.
INumerable of employee.
I'm living on the first floor, but I'm going to jump out of my first floor window if I don't hear the right answer.
Object of employee.
is the wrong answer. I enumerable of employee. Luckily, my window has grills on it. Yesterday, 50 times I must have asked you, see, what does that return? What does that return? What does that return? Because if you understand what it returns, then link is easy. If you don't understand what it returns, and if you felt that why is this guy asking me 50 times, the answer is this. I want you to get bored of giving the right answer. So this returned not an employee, but it returned an IEnumerable of employee. This. And then from there, I'm doing where. So are all these three the same? Are all these three the same?
Yes, sir.
Yes.
Agree? But there is a big difference in all these three. There's a big difference in all these three. Let me show you how it matters out here. What you write first, how it matters. So let me comment out this. Right. Now, what if I said from this, see, this is picking up all the employees whose basic is greater than 10,000. Okay. From this, I want to pick up only the names. From this, I want to pick up only the names. So let's comment out this for now. And let's comment out this for now. So what have I said now? Pick up all employees whose basic is more than 10,000. What is the return type for this data? What will this return? Don't tell me employee. If you tell me employee, I will throw something at you.
So IEnumerable of employees.
IEnumerable of employee. And from that IEnumerable of employee, what are you going to now pick up now?
IEnumerable of string.
We are picking up only one column from there. So what is this returning? What is now this returning? It's returning a IEnumerable of string. So what is there in EMS2? What is there in EMS2? Yes, is IEnumerable of string. So if this is an IEnumerable of string, what is item now? What is item?
One
string.
String of name.
One item, which is a string. An item dot would give you properties of the string. So have you understood this one? Yes. All right. Now, what if I did the same thing here? What if I did the same thing here? Is line number 309 and line number 310, are they the same? Is line number 309 and 310, are they the same now? Earlier we saw that, you know, they were similar. But now is it the same?
So after fetching an IEnumerable of string, it won't be able to fetch IEnumerable of employee.
Correct. Well spotted. That was going to be my next question. So our first question is, what does this return? What does this return? IEnumerable of string. So if you look at string dot, you don't get any other properties. You are only getting properties of string. So now if this is an IEnumerable of string, what is E now? If this is IEnumerable of string, what is E now?
Property of that
is one string.
Yes.
E is one string. Now, does a string have a property called basic? Answer is no.
No.
So this actually gives you an error. This gives you an error. Saying what? That I don't get basic. If I did E dot, see, look at what where takes as a parameter. What is it taking now? Func of string comma bool. Because this now the left hand side, this part here is an IEnumerable of string. So you cannot be now saying, if E is a string, you cannot be saying E dot basic. So this does not work. This is logically incorrect. Syntactically also incorrect, logically also incorrect. Are you understanding why the order makes a difference? Because you're first doing what? You're first saying, okay, this query will return something. And based on something, you're writing the second query. So the first query returns the whole object, then yes, you can use the second query to do that. But if the first query itself is now changing what the original object was, then the second query cannot access the original properties of the first object. So which is why the order of the queries matters. All right. So in the first example, in this example, why didn't it matter? Line numbers 304, 305, and 306. All three of them returned the same output. Why didn't it matter there? Why didn't it matter there? Why didn't the order matter there? All three of them on the earlier this thing are giving you the same output. 304, 305, 306. Why are they not? Why is the order there not mattering?
Because that enumerable type is of employee.
Because we are picking up the whole object. We are picking up the whole employee object and returning an enumerable of the employee. But in this example, we are not picking up the whole object. We are picking up part of that object. So if you're picking up part of the object, then you can't write code for that. For the other part. Actually, tell me now, instead of e.basic, if I take an e.name, would it work? E.name would have worked, no?
Yes, sir.
Yes, no? Yes?
No, sir.
No,
No,
sir.
sir.
Why
No,
not?
sir.
Are I am saying e.name here. I'm giving e.name here. So e.name here should work.
From name we
It is
cannot
not a property of string.
Sir, string doesn't contain name.
Correct. Because this returns an enumerable of string. And string doesn't have a property of name. What is E now here? E is not an employee. E is not an employee. What is E now? E here
Enumerable
is a
of string.
String.
E is a string.
String.
One object in that. So even something like this will not work. Are we getting this, everybody? So bottom line, see the way in which it's returning the values. The output of the first query, will be taken as the input for the second query. Okay. So this doesn't work. This here, of course, is an error. Right. And so when you're combining the two, be careful about this. Clear? Everybody? Are we clear on this? So this is how you use the where. Let's take it further. Okay, now the remaining ones now that you understood this, now we're going to speed through, and now you are going to give me the code. I'm still, not 100% okay. So I want to talk less. I want you all to talk more. The next one, of course, we had used was the next one was, yes, the order by. Okay. So let me write down this query. Sorry. I need to come back here. And write down this query. So this is the query that I wanted to write. Instead of using the longer expression out here, I want to use the lambda. So help me. Where EMPS is equal to, what would this be? LSTMP dot, any guesses?
Order by.
Order by. No prizes for guessing. All right. Order by. What does it take here? Take a func as a parameter and return t key. T key meaning what? Any one value from there. So what does it take as a parameter? Take an employee as a parameter and return what? E dot whatever name, let's say. So what is doing? This sorting it, ordering it on name. Okay. Is this ascending or descending?
Ascending.
Ascending.
What if I
Ascending.
wanted descending? What if I wanted descending? I
Yeah.
don't know. Do you
We
know
have
this?
we have to mention.
There is another method for order by descending. So there's a method here for order by descending. What if I want to sort it on two things, like here, like I did here, like I did here. I want to sort it on two things. So help me. Help me.
So we will have to write order by 2 times.
No. Trick question.
So first we need to sort on one parameter, then dot, then we can sort on another parameter.
Right. But this is a trick question. This is a trick question.
Okay.
So listen to the answer. I'm saying LSTMP dot order by. So first one is okay. Order by what? Let's to keep it simple now, I'll not keep descending right now. So order by what now? First one, take E as a parameter and sort it on E dot department number. This is the first one. Now for the second one, don't give an order by again. Because if you give an order by again, then it loses the ordering of the first one. So syntactically it is not incorrect. But what will it do? It will lose that department number order by and again order it by what? Name. I'll show you what I mean by that. Supposing I did this, like what you all were suggesting. So take what E and order it by E dot name. So let's say we do this. All right. We're doing this. And now I'm going to display the items. I'm going to display the items. So we have name here. So if you do EMS2 rather. So department numbers was what? 10, 20, 30, 40. But department number 10 is not coming in first. 20 is coming first. So why is it taken 20 first? It should have taken 10 first. No? What has it sorted it on now?
Name.
Only on name. So it did what? It first sorted by department number. But then the second time it resorted it all over again on name. So we don't want that. We don't want that. Instead of order by again, you have a then by. So then by means first sort it on department number, and if the department number is same, then sort it on name. So within the department number. So that's the difference. You don't give two order bys. You give an order by and then you give a then by. So now see the output for this one. How will it take it now? How will it taking it now? The department numbers 10 is coming in first, and within that it's sorting it on what? Within that it's sorting it on name. Okay, so it's a big difference. Supposing I had given this and I had given descending. Helping with this, what would I have then written down this code as? What would be the then here code as what? Yes.
So we have a then by descending.
Very good. So then by descending. So that's what you do. So if you want the continuation, then the then by or the then by descending. So this is how you could use the order by. Clear on this? Okay, let's take this further. In fact, let me copy paste this code only. Okay, I don't know why I copy paste. I could have just written it down. Next one that I want to take up here is what?
Join.
Is the join. Okay. Okay. So this is the original statement. This is the original statement. Okay. Now I'm going to again copy paste something because I got few things, multiple things written down there. So I don't want to type out all the code. Okay. So let's look at the join out here. Okay. Before we get into this section of the code where we are writing it differently, let's revisit what we did yesterday. So from EMP in LSTMP, this is yesterday's syntax. If LSTMP is a list of employees, what does that make EMP?
INumerable of employee.
9
One.
Single object.
Sir, employee.
is one single object.
Single episode.
Yes, sir.
This is like a for each loop. This part here is like a for each loop. So if LSC department is a list of departments, what is DEPT now again?
One object of department.
So which is department. So we have given these two things. And then we have also given, what have we given here? What have we given here? What are the two columns that are the common column between the two? And what are the last part that we are given here? Last part that we are given here is what?
Employee.
Select what? Select what?
Single.
Yeah. So did we try the variations here? Did we try all the variations here? Wherein we are either selecting a single employee or selecting a single department or selecting what?
Anonymous type.
Anonymous type which contain the employee and the department object, or selecting an anonymous type which contain what? Some properties from employee and some properties from department. So these are the variations that we tried yesterday. So this is the same thing I'm going to try today. Same thing, exact same things. So let's look at this. So we say var EMPS is equal to, let's start with LST EMP dot join. Okay. Now what I'm going to do here is, as I type this out, okay, as I type this out, I will show you what all I have included from the previous query. So LST employee dot join. So what have I already given? What from this line number 347? What have I already given out here? What have I already said? Let's write is list employee. So I've already given list employee. So LST employee dot join. I've given the join word. I'm not removing the join word. What does it take as a parameter? What does it take as a parameter? It takes an INumerable of T inner. So what is the other collection that you want to take? What do you want to join it on? So what is the other collection that you want to join it on? LST employee, you want to join it on what?
LST
Department list.
LST department. So the parameter that I'm giving here is LST department. All right. So I'm removing LST department because I've already given LST department down here. That's the first thing. Second thing. So this was my other collection, INumerable of LST department. What is the second thing that we have here? What does it take? It's saying func of employee comma T key. So it's asking you which key from employee you want to take. What are we talking about here? We are talking about line number 349. You're saying join it, and then this is the two columns that are common out here. So what is it first asking you for? Which is the column from employee, which is the common column? So which is the common column from employee? What is it called?
Department number.
Department.
Department number.
So it says take an employee as a parameter, and return the common column. So what is the name of the employee object? I'm calling it EMP. I'm calling the name of the employee object as EMP. So take an employee as a parameter and return EMP dot department number. That's the second parameter. Now, what all have I given in here? I've given the name of the employee object. So I'm removing that from here. And second thing, I've given what? I've given what here? What is this? Name of the common column. So I'm removing that from here, saying that I have already given this. That was the first thing that we did. Look at the next parameter. What is the next parameter saying? Func of T inner comma T key. So the other collection that you had, all right? See, this is a func, enumerable of T inner. They're calling it T inner. So this is the other collection that you had. Take one object from that collection and specify the key of that other thing, which is the common column between the employee and the department. So here I'm picking up department and return department dot department number. So what are the two things that I've given in here? Two things that I've given here is what? I've given the name of that other object and the what?
Common column.
And
Department number.
common
Second
column from there. So all this I've given so far. So far I've managed to give in all this. What is the only thing remaining? What is the only thing remaining?
EMP.
What do you want to select? What do you want to select? Now, what can you be selecting? What can you be selecting? You could be selecting one object. You could be selecting a combination of, objects out here, or a combination of columns. All of this you could be selecting. So this is what I'm giving the last one here now. Coming back to this. So the last one, let's get the last parameter. What does it say now? Take a function which takes an employee and a T inner. What is my T inner right now? T inner is department.
Department.
So take a function which takes two parameters, employee and department, and returns what? T result, which can be anything. Can be one column, can be one object, can be combination of objects, can be combination of columns. So this is the last thing. Now I've got a function that takes two parameters. How do you write a lambda for a function that has two parameters? What do you need to do?
So add parentheses.
Right? Parentheses, I'm giving the two columns. So that's what I'm giving. I'm saying take an employee and a department as a parameter and return. If I have to write down line number 350, what will this be? If I have to write down line number 350, what will this be? Return
EMP.
what? Return EMP. So this is your query that you're written. Okay, this is the query that you're written. LSD employee is this LSD employee. LSD department is this LSD department. EMP is this employee. EMP dot department number is this employee dot department number. Department is this department. Department dot department number is this department dot department number. And lastly, what you're returning here is what you're returning here. So that's how you write the syntax which uses the lambda. It looks complex, And the first time you look at it, I will agree with you, it looks really complex. But if you understood yesterday's join statement and how that worked, then today's thing is just a alternate syntax wherein the same fundas are used, but with a slightly different syntax. So this was returning an employee. Now look at my variations to this. Look at the last parameter. Instead of returning an employee, what could I return out here? What am I returning? What is this returning?
Department.
The entire department object. What else could I return? One column from employee or one column from department or employee comma department. What is this doing? What is this returning? The entire employee object and the entire department object. Or what are we doing here?
One column from employee.
One column of
from
employee, one
department.
column
Some
of
columns.
department.
I've written only one, but some columns from employees and some columns from departments. Are we clear on this? So this is how you would give it. The earlier part will not change, only the last part will keep changing. So that's what you're doing for displaying these values. Okay. I'll keep the last option here. And you can then try looping through it. Questions, if any? Right, you need a lot of practice in trying out this example and trying it out with different variations so that you get mastery over this. All right. The good news is that I have finished the examples that I want to show you in Link. That's the good news. The bad news is these are not all the examples that are there in Link. Link has so many more options that are available out here for you. So I'm going to give you a small, to do for later in the day. Is you have to go through the site. It's linksamples.com. Right, I'll paste it in there. I'll paste it in the documentation out here. And in there, they've given you examples of how to use link queries with many more functions than what I have covered. So you have to do those a little later in the day when you're in the lab. Okay. All right. I'm not done with link as yet. I still have a few more concepts to cover. But from the functions point of view and from what you're using out here, this is what I wanted to cover with you. Okay. All right. Okay, now I'll take you back to the first example of link that we tried out. The first example of link. So this is how we wrote the query, where m is equal to from m in LST employee select EMP. All right, this is what we had done yesterday. First example. Now, when you write a query like this, by default, it uses something called as deferred execution. Deferred means happening later. When you defer something, you postpone it for later. So what do I mean by deferred execution? It means that this query is not executed on this line. This query is not executed on this line. So it's not actually happening on line 368. That's not what's happening. Instead, this query is actually run at a later point of time. So when is it actually getting run? This query, or I'll put it this way, when is EMPS getting formed? When is EMPS getting created? EMPS is getting created not on this line, but EMPS is getting created when you try to iterate through EMPS. That's when this query is run. And this feature is referred to as deferred execution. So I'll explain to you what I mean by that. So for example, initially, how many records did we have there? Initially, how many records did we have there?
8.
Total of 8 records.
8.
8 records, correct? So if I ran this query, you got 8 records in the output. Okay. Now, if the query was formed here, supposing the output was formed here, supposing EMPS was formed here, supposing it was not deferred execution, supposing it was immediate execution, and you got value of EMPS here, and then I remove something from LSTMP. LSTMP had 8 records. EMPS, assuming it is formed here, will now have 8 records. And now I remove from LSTMP. How many records should EMPS have? How many should EMPS have?
8 should
Sir,
have
8.
8 only, correct? Because you are removing it from the other collection. So when I loop through EMPS, I should be getting how many? I should be getting all 8 records. But when you try running this loop, you don't get 8 records. You will only get 7 records. So the first record is going to be deleted. Vikram's record is going to be deleted. Are we clear on this? Let's try running this. Let's run this and show you. So you'll find that it started with employee 2. Right? It didn't have employee 1. So why did that happen? Why did that happen? I'm saying this happens because of a feature called deferred execution, where the output is not formed here. Output is not formed here. Where is the output being formed? Where is the query being run? Where is the query being run? Where
During
is
the
this query
storage
being
loop.
run? When you are
Inside
trying to
storage
loop through EMPS. When you access EMPS, at that time, this query is run. So when you are accessing it here, now how many records does LSTMP have? How many records
7.
at this point? It has 7. So it will actually show you those 7 records. Are we clear on this? Okay, what am I doing further in the code? What am I doing further in the code? At this point, what am I doing? Adding to where? Adding to LSTMP. And again, if I now pick up from EMPS, now what would I get? I will get this 9th employee that I've added out. I'll get that. Even though EMPS initially, didn't have that 9th record. So I've removed 1 and I've added 1. That's what I've done. So initially, got 2 to 8. And then after you add it and loop through it again, you got 2 to 9. So this is how it behaves by default. It uses deferred execution, which says that the output is formed not when you write the query, but when you loop through the output. That's when the query is first executed. And this is executed every time. You see what happened here. Second time also what happened? Second time also I ran the query. What is it doing again? Again picking that from LST employee. So every time I read the value from there, it's going and refreshing the values from the query. Now you may want that to happen. In certain situations, you want that to happen. Why would you want it to happen? What is the advantage of doing this? What is the advantage of doing this? What is the advantage of deferred execution?
Updated list will come into picture.
Sorry?
Updated list will come
Correct,
into picture.
correct. You're getting the latest values. You're getting the updated values. And this is by default. You didn't need to do anything for deferred execution. But in certain situations, you may not want deferred execution. You might want what is known as immediate execution. Immediate execution is the exact opposite of deferred execution. So immediate execution says that where you're writing that code, at that point itself, I want the output to be formed. I want the output to be formed at that point itself. I don't want it to be, updated later point of the time. And let's see how we can use immediate execution. So for immediate execution, you need to make a call to either to list or to array or to dictionary. You need to make a call to either to list or to array or to dictionary. What do you think to list returns? What do you think to list returns? As the name suggests, to list will return what? Look at this. Returns a list of employees. What will to array return? What will to array return? Yes.
Array of employees.
Array of employees. And what will to dictionary return? Right. What will to dictionary return? Yes. What is the
Dictionary of
employees with a key and a employee as a parameter. So why is this giving an error? Because to dictionary requires you to pass what? What
Key.
should be the key now? So take an employee as a parameter and tell me what the key is. Right? So take an employee as a parameter and give the key. So what could be the key here? What could be the key out here? E dot employee number could be the key. Are we clear on this, everybody? Right? Okay, why is it
sir, as a parameter, right? So E dot EMP number, won't that be a return type?
which
Achha,
one?
okay. So you are returning key to the dictionary through E dot
Yeah.
EMP number.
Okay. Now, when you do this, it does not automatically convert it. So you are expected to give in a typecast. So what are the typecasts that you are giving out here? Dictionary of int, comma, employee. Right? And okay, it's still giving an error, is it?
So one extra bracket.
Even this. Okay, I'm not sure why this is giving an error. Okay. It's still not. I'm not too sure about this. Let me get back to you on this. What is the, I don't want to just give you some random code. Give me a minute to work that out, and I'll, just maybe post the break. I can tell you the exact syntax of what I'm making a mistake on. Okay. So I'll keep it back to the to list. And I'm also saying that immediate execution can be done with a 2 array or a 2 dictionary. And this is what I would need to do out here. So I'm converting this to a list out here. So what does EMPS contain at this point? At this point, it will actually go and fetch the records from here. See, remember, fetching is not happening here. Fetching is happening where? Here. Now, if I try the same code as the earlier one, so I've converted it with immediate execution. I've got into EMPS and I remove from LSTMP. I'm removing from LSTMP. So when I go through EMPS, would I get 7 records or would I get 8 records? I've done immediate execution. So would I get 7 or 8 out here?
8.
Removing from LSTMP. So this gives you the 8 records that you wanted. Right. And if you try running this, you got the record numbers 1 to 8. Similarly, if I tried adding something to it, later if I tried adding to it, LSC employee.add, but if you go through EMPS, this is again giving you what? The same records as before. 8 records as before. If I press enter, again 1 to 8. So changes made in the original listing will not affect your values that you got with immediate execution. Are we clear on this concept? Generally an interview question. What is the difference between deferred execution and immediate execution in link? Right? And explain how deferred would work, how immediate would work, and when should you use immediate, when should you use deferred. This is what you could be doing.
So when should we use deferred and immediate?
Not default, deferred.
Example.
Deferred.
Yes, sir, deferred.
I'm saying that if you want the latest values, you use deferred execution. As simple as that. That is the standard behavior. You don't need to do anything. It will always give you the latest values. But if you wanted the values when the query ran and not the latest values, then you use immediate execution.
Okay, sir.
All right. So this is the link samples that I was talking about. And if you look at the link samples, right, they have grouped it into different types of queries. Like, for example, aggregate queries, like, average, aggregate, average count, long count, min, max, sum, right? So they've given you different examples of all of these. They're not using a collection. What are they using in their code? An array. But whatever you're doing with that array, the same thing you can write with a collection also. They're actually doing it with a string array, right? But you can use it with a, with a different type of example also. Or if you, try the select, for example. Okay, so they're given select out here. Now they've given you both the syntaxes. So you will find that you got the lambda syntax. You got the lambda syntax as well as the query syntax. Okay, so look here on the top, lambda and query as well. Now, if you go in for some of these, like let's say if you go in for count, now they're showing you the lambda. They're showing you the lambda syntax. But if you go in for query, it does not have an option for count in query. So the only way you can use count is with the lambda syntax. Now, everything that you can do with a query, you can do with a lambda. But there will be additional things that you can do with the lambda that are not possible with a query. So most of link, options that you see in most websites or even, in your other code that you will write, people will prefer using the lambda to the query purely because things that you can do with the lambda cannot necessarily be done with the query. Okay. Now, from this, there are some functions that I would like you to try out in detail. Look at all of them. There are a lot of them. I think there are about 100 examples there. So look at all of them out there, but some of them I want to try out here. The ones which say element, okay, all of these. So let's look at all of these one by one. Element at. Any guesses what that would give you? Element at.
Element at an index.
Correct. So element at an index. So if you look at this code itself. It says what? Words dot element at 1. So what is 1? Index number 1 is actually 2. All right. So that's what's giving it to you out here. Now, what if I gave element at 5? What if I said element at 5? What would happen now in this case?
Exception.
Null pointer.
He'll give you an exception, saying that there is no element at 5, index out of range or something, some exception to that effect. All right. Now, to avoid the exception, you can use element at or default. Now, supposing I gave element at 1, what is this giving you now in this case? What is the
Green.
element at? I'm just saying not element at or default. I'm saying element at would give you green. And element at, only element at, not the or default, at 10 would give you an exception. But if you use element at or default of 10, and if this 10 does not exist, then it will give you the default value of that element. And what is the default value of a string? In this case would be null. So if you're using this with an object, it will return a null. And if it is using it with an integer, for example, it'll give you the default value of an integer, which would be 0. Are we clear on this, everybody? So you'll find that there are all these at, element at, or default. Okay. First, any guesses what first would give you? Come on. First.
So first object.
The first option from there. Or you can give first with a condition. So what are we seeing out here? What are the condition out here? First one whose length is 6. Now there are 2 of them. Sweden and Norway, both of whose length is 6. So what can you give out here? Now in this case, what will this return here? Would be the value Sweden. Okay. Now first or default, if not found, would give you the default value. If found gives you that value. If not found, gives you the default value for that. All right. So you can try out all these. Similarly, last. Instead of giving the first, it's giving the last. Now I'm going to try out one example with this, which is the single. Single looks and says that I want exactly one occurrence of this. So let's see options with single. All right. Okay, what is single returning here? If you're doing it for LST employee, what will one object of this return? Single object of that would be what? Would be one employee. So return type for single here is an employee. Okay. Now let's say I said basic, or let's not give basic. Let's say E dot employee number equal to 1. What is this going to return? What is this going to return?
One employee object.
One employee with EMP
Single
number
object only, whose employee number is 1. So if I run this code now, what would be the object that will be returned here? What will be the object? Whom would it point to? Employee number 1. Right. So if you look at this now, this contains Vikram's record because Vikram was employee number 1. Okay. Similarly, if I had said employee number 2, this would give you employee number 2 in there. So looking out for a single record out here. So this is second record was Vikas. Right. What if I give employee number 10? What if I give employee number 10? What do you think it will do?
Null.
Single. It's looking for a single record whose employee number is 10. What do you think this would do?
exception.
Let's try this. Right? Invalid operation exception. Saying it cannot find it. There is no one. Right? Sequence contains no matching element. So this also gives you an error. Okay. We're not using single or default. We're using single. What if I give you this condition? How many records am I getting for this condition?
Multiple records.
Multiple records I'm getting. And if I run this now, I'm saying I want a single record which matches that. I'm not saying first or last. I'm saying single. So what is the error now? In this case, sequence contains more than one matching element. So if you want to work with this again, you can't work if it's going to give you more than one record. Are we clear on this, everybody? So if it worked correctly, perfect, no problem. If it gave you no records, then also error. And if it gave you multiple records, then also error. Okay. One record is okay. All right. Now you have something called single or default. Single or default. So let's try the same thing with single or default. Single or default. All right. Let's try the same thing with single or default. One record. What will happen? One record. Exactly one record. Then what?
That record will be treated single record.
No problem. This works exactly the same way. So this gives you the correct value. You can carry on with your code. And EMP right now, of course, is pointing to Vikram. So it gave you that record. Okay. What if I gave you a record that was not found? So one record is okay. This is not found. What will this give you? Single or default? Single or default? What will this give you?
Null.
If no records are found, then this will return a null. So let's look at this. Code didn't give an error. EMP now points to null. So you could check for whether employee is null or not null and work with it accordingly. Achha, now very interesting. Single or default for multiple records. single or default for multiple records. Let's look at this. We're not even getting single, and we are not even getting no records. If it was no records, it was giving you default. What is this giving you? Multiple records. So when you do multiple records again here, again what? Exception. Are we clear on this, everybody? So this is how you could actually, check this out and get how to work with this. So try it out with different options and see how it works. I've given you the side what are the options out here. And try out all these. Try these out. Try out all these. We will be using them in the future. Clear? Okay. This is one thing for you to try out. Six, where will be 7. All right. Now consider this situation. What if you had a lot of records that you wanted to query? You had a lot of records that you wanted to query. Now, to query those records, when the number of records are very large, right? You can speed up your work by breaking up the number of records into equal parts, into multiple equal parts, and running each part on a separate thread. Okay, so supposing I have got 100 records and I want my query to do something. So it wanted to process those 100 records. I'm saying that instead of running all those 100 records on one thread, what can you do now here? Run it on 2 threads. So the time that you will save there will be a lot. It won't take you as much time. It will reduce the amount of time that you have out there. Provided, of course, you have multiple processors. We've discussed this before. If you got a single processor, then it really doesn't matter. If your machine has got multiple processors, then you would need to do that. Are we clear on this, everybody? Now, how do you do this? To do this, you have something called as P-link or parallel link. And what P-link simply does is allows you to write your link query the same way, no changes there. All your syntaxes will be the same, but you specify that this should run in parallel and how many threads simultaneously would you like to run on that? Okay, so these are things that you can do to speed up your work. So I have one small example of P-link. Okay, let me show you that example. I'm not copy pasting it. I'm just running it from here itself, and then I'll copy paste it later at the end of the session. So that will save me some time. So look at the code that I have out here. First thing is I'm calling address2. What is address2 doing? What is address2 doing?
Adding employee object.
Adding employee objects in a loop. Right? Adding employee objects in a loop. So adding 200 employee objects. After adding 200 employee objects, I am writing code to process that link query. Now see what I'm doing out here. Look at this code first. What is the first thing that I'm doing? lst employee.select, take an employee as a parameter and return what? Return what? Name is equal to, I'm calling a function that is doing something to the name. So I'm going to pass something to that function. And what would the function do to me? Do for that name? It will just simply do some calculations on that name. Now let's assume that this function is a long running function. I'm purposely putting in some delay out there to indicate that there's a lot of processing time happening out there. So this is returning name and employee number. These are two things that it's returning from that function. But only difference is now that this function here, long running function, what have I introduced out here? What have I introduced out here? Is a 10-second delay.
Sleep timer.
10-second delay. 10-second delay indicating that this function will, do a lot of processing and then return the value. And all that I'm doing here is what I'm just taking something very simple. Whatever the name I'm returning to upper of that name. So whatever name I'm passing, I'm passing Vikram actually. Vikram is being converted back to a uppercase string and being returned. So this is what this code is doing. All right. And then I actually go and display the values here. So I display the employee number and name. I'm displaying the values here. But to show you how much time it takes, I've created a stopwatch, which is in the system.diagnostics namespace. I've created a stopwatch, and that stopwatch would simply calculate how many seconds it took to run this code. So let's try running it first without peeling. And somebody keep track of this time. So it's about 3.2 seconds is how long this code took to run. Okay. So 3,200 milliseconds. All right. Now the same query, this exact same query, I'm converting it to a p-link query. And to convert it to a p-link query, there are a couple of things that I'm doing. First thing is I'm saying as parallel. As parallel. So what is this as parallel doing for me? Saying that this query is now a p-link query. So to make any query a p-link query, you call a dot as parallel. Okay. The second thing that I am doing out here, I'm specifying with degrees of parallelism. So this is how many threads you want to run on this. So how many threads you want this to be run on 2 threads. I'm specifying. And then the query is the same. The query is the same. So this part here is the same. This part here is the same. So there's no change in the query out here. Okay. The remaining query is the same as what I have written on the previous slide. The only difference is this. Saying now that break it up into 2 parts. So what it will do is whatever records that you have, it breaks it up into 2 parts. And let's run the same code. Earlier it took about 3254, right? If I remember correctly. And now it took about 1827. Right? So it's about little over half. Why little over half? Because there will be a slight overhead in creating the thread and all of that. That part would be there. But as your number of records go up, then this difference would be minimum. So it's about 1.8 seconds as opposed to 3.2 seconds for your running your code. Let's increase. Okay, or let me run this one more time. Let me show you one more time. And if you see the output, my record numbers start from 9. I shouldn't have done that. 1 second. That was I was just showing some kida to someone. Okay, somebody asked a question and I answered that and I made a change. So look at the record numbers. Employee number starts with 0. So 0 to 99. 0 to 99 are the first set of records. And 100 to 199 are the second set of records. So do you see how it has done this? 100 0, 101 1, 102 2. So it's taken one record from one set, one record from the other set. It is broken it up into what? Your data, it is broken up into two parts. One part of the data from 0 to 99 will be run in one thread. And from 100 to 199 will be run in the other thread. That's what it has done. If I increase the degrees of parallelism, what are degrees of parallelism? This is actually nothing else but number of threads. If I increase that to 4, how many sets is your data now? 200 divided by 4. So each one would have 50. And we ran it earlier to the 1.8 seconds. It will be far less than 1.8 seconds. So if you run this now, it's about 928 milliseconds. So roughly half of that. As opposed to how much? Earlier, first time we ran it was how much? 3,000 something odd it was. 3,000. 200? 3524 or 3254 or something like that. That was the first time you ran it. Now it's come down to 928 milliseconds. Now you can increase the number of threads again. Let's say 8. Right? Now this is not drastically reduced, right? Because it also depends on how many processors are being used to actually do this. So it's not half of it. Also, there's an overhead out here. So this, with larger number of records, you will find that there are more differences. But it is reducing as you increase the number of threads. Are we clear on this, everybody? So I have put a short listing to p-link, and there are more options to p-link. Like for example, we have tried out one of these methods. What are the first method we tried out? As parallel. Right? Now, if you don't want it as parallel, then by default it is as sequential. Okay. Now, if you wanted the output to come in an ordered manner, then you put it as ordered. Like in our case, what are the output coming out as 1 and 2, 1 and 2. I mean, from one from each set. So if you'd like to retain the ordering, then you can give it as ordered, but this runs more slower than the as parallel. So try out all of these. By default, it is as unordered. With degrees of parallelism is what we have tried out. Okay. So this is the one that we have tried out. And then there are a few others also. I'm not going through all of them. You can read up on those. That's beyond the scope of what we are doing out here. So do read up on that. There's also another p-link example that I've given you. I like that article, so I just put up the link out there. But this is a very, my code is very old. All right. So I'm not sure whether the article is still there or not, whether it's still working or not, the code in the article, whether it's still working or not. You can try that out. But okay. All right. Now I'm done with my examples on link. So I'll just copy paste this last example. This was, the one that I just showed you, and you can try this out, but I'll do this offline. I'm stopping here for this session. Okay, stopping here for this session. You can take your break and we will start the session again at 12:30. Okay, I'll take about 5 minutes to copy the code. People can join in as.
Yes, sir. Yeah.
So one of the things that we tried the other day was writing asynchronous code with delegates. Now, when you work with delegates and you say delegate object dot begin invoke, what is that begin invoke statement doing for you?
Creating a thread.
All right. Actually, the slight change. It's running that code on a separate thread, but I won't use the word creating a thread. I'll explain why not creating a thread a little later in this session, but that doesn't create a thread. It runs your code on a separate thread. Now, when you use a delegate, you are not having a lot of control over how that thread is running. So the delegate actually, I mean, I'll talk about this again when I talk about the thread pool. But the delegate actually uses an existing thread and you don't have a lot of programmatic control over how that thread is running. Okay. If you wanted more programmatic control over how that thread should run, then you can create your own thread class. You can create an object of the thread class rather. So you have a namespace system.threading wherein there are inbuilt classes which allow you to manipulate threads. So one of the classes there is the thread class, right? Okay, I'll come back and write down the code for this. Now in this sample example that I have taken up, I've got two functions that I'm writing, function 1 and function 2, both of which are just simulating some work that is being done. So in both cases, I'm just putting out a simple, console.write line, which is showing me that either the first thread is running or the second thread is running. I want to call this code asynchronously, and I want to actually run it in a separate thread. So to do so, I will create an object of the thread class, and this has various options out here, one of which takes a thread start as a parameter. So if you look at thread start itself is a, what is that? If you can see this, look at the symbol should be enough, is a delegate, and look at the signature of this delegate. Can point to a function that has a void return type and does not have any parameter. So that's what you do with thread start. So one of the functions here, func1, for example, is what I could use out here. And I'm making T1 point to func1. Okay. Not new func1, but new thread start of func1. Right. Obviously, I can write this code in a much shorter, easier way. What is the easier way in which I could do this? Directly given what? So giving this directly given the function name without creating an object of that delegate. So which is exactly the same. We've seen this with delegates. So at this point, T1 actually points to the function, but the thread has been created but not been started. So it has actually two different modes. We'll see what is something called as a thread state. So the thread at this point has been created, but has not been started. To run the thread or to start the thread, to run that function, you would actually write code in this manner, thread.start, t1.start. And what would this do for you? This is similar to calling that function. So at this point, your code would run. It will do whatever you're actually doing. So total of two threads have been created, the main thread and this other thread. Okay. Let me create similarly another, just like I've created T1, I'm going to create another T2 and make it point to the function 2. Right. And similarly, I'll give a T2.start. Again, this is asynchronous code running. It's not going to wait for anything else to happen out here. And for good measure, I'll put in a loop in the main thread as well. right? So I actually have got 3 loops going simultaneously. So this is the code in the first, in the main thread. And then this is the code in the first thread that you have created and the second thread that you have created. So all this is doing is just simply giving out output on the console. Let's try running this. And a total of 3 threads running right now. Right. So you'll notice that, for some time thread 1 ran, then sometime thread 2 ran, main thread ran for a while, and so on and so forth. So this is how you're actually getting the output. The output that you get may not match this, it might be slightly different. But if you notice, it's actually each of these is running for a certain amount of time. Okay. At some time, at some point of time, that's the main thread. The main thread is over at this point, right? At this point, the main thread gets over, and then it continues with the execution of the first and the second thread. So at this point, the second thread got over. I've set less than 100. And then after that, what runs, of course, is the remaining code of the first thread that you had created. So this is how you can actually create a thread object and work with it. What in this example, what did we pass as a parameter? What did we pass as a parameter? The thread start, which is a delegate, which points to a function that has a void return type and no parameters. So that is first possibility. You can call a function with no parameters and a void return type. You can, now that you've created an object of this thread class, you can control this thread a little bit. So let's see how we can set a few properties of this thread. Right. Let's look at some of the properties of the thread. I could abort a thread in between. So I've started a thread and I could actually abort a thread. So t1.abort, for example. What do you think abort would do? What do you think abort would do?
And that thread.
Terminate that thread in between. So even if the thread is running for a while, right, it would actually stop running that thread abruptly. Right. And let's try running this. So I don't know the main the first thread got a chance to start or not, or it was aborted initially itself. So it got aborted initially itself, even before it started running. So let me put it in a slightly different later point. Okay. What I'll do is here is if I equal to, let's say 50, then t1.abort. So I'll abort it when the value of this I reaches 50. So it should allow it to run for a while and then abort it. So you'll notice that the first thread was running. The moment main hit 50, the first thread was aborted. So, it did come out with one statement, but before it could do anything else, it was aborted. So there's nothing else after that. So when main has hit 50, first has got aborted. Right? So you could abort a thread. What are the other things that you could do with this? Okay. All threads that you create are by default foreground threads. So what do I mean by a foreground thread? Just have a look at this. What if I don't have a read line? Let me comment on the abort. What if I don't have a read line? What will happen now? What will happen now if a read line is not there? Can you tell me how this code would run if there was no read line?
So it would run the same way.
There would be a difference. At the end of this code, your main function ends. Right? Now, two possibilities exist. one possibility is that the other threads have not yet finished executing. That is one possibility. So for example, let's say if I given a very large value here. So this first thread is going to go on for a very long time, T1. And the other code finishes. Now T1 is still not finished. Now the main function is ending here. So the main thread is ending here. Now the question is, should it wait for T1 to finish or not? That is the question. If the main function is finishing, should it wait or not?
No, sir. They are independent.
By default, it waits. By default, it waits. So how does it decide whether it's waiting or not? If your thread is a foreground thread, then it will wait for that thread to finish and only then end the main thread. So it waits for that thread to join back, foreground threads. But if the thread is not a foreground thread, right? If it's a background thread, then the difference is the main code does not wait for that thread to finish. Now, by default, what did I say? All threads by default that you create are foreground threads. So right now, is it going to wait for this one to finish? And the answer is yes. 10,000 is too much. I'll make it 1,000, let's say. And please look at the output. So now first thread is going on. Okay, ran too slow. I couldn't get to talk what I wanted to. Maybe 5,000. Right. First thread will still be going on. Right. And when the first thread hits 5,000, right, and then the first thread ends, that's when the main thread is ending. This is because currently it is a foreground thread. But supposing it was a background thread. Now, how do you make it a background thread? You could do this T1 dot is background and set it equal to true. So what will happen now in this case? What's going to happen for a background thread? Wait for it. Let's run this. And as soon as main finishes, gone. Even though the first one was running, as soon as main finished, what happened? Done. Are we clear on this, everybody? It didn't even wait for the other code to run. If this code was not a background thread, then it was waiting for it to finish. So that's the difference between a background and the foreground thread. So threads that are not critical can be made background threads. So even if you don't finish the thread and the program ends, it should not by default wait for it to finish. All right. When you are running threads, how much time slice that thread should get is decided by the CPU. CPU is responsible. We talked about this on day one. One of the functions of the CLR, not CPU, sorry, I said CPU, I meant CLR. One of the functions of the CLR is threading is controlled by the CLR. And how long that thread should run is managed by the CLR. So you can't specify that this thread should run for a specific time. But what you can do is you can give it a priority. Okay. And there are 5 priorities that you can give. Right. So it's an enumerated value. And there are 5 of them. So look at what I'm doing. Right. So the default value is normal. This is normal. Right. Look at me. There's one above normal. This is normal, above normal, and highest. So you have highest, above normal, normal, below normal, and the lowest. These are the 5 priorities that you have. So for example, if I give it a higher priority. Let's say I say this should have the highest priority. Then the CLR will give this a larger time slice. But you still don't have control over how much exactly, right? You have to leave it to the CLR. So threads that are more important, that should, get more time, can be given a higher priority. Okay. Okay, one of the methods that we saw there was abort. Now, what can you abort? Which thread can you abort? Can you abort any thread?
The thread which is started.
Yeah, the thread which is currently running. So if you try to abort a thread, for example, which is not started, it will give you an error. Or if the thread has finished executing, it will not, it's not running anymore. It will give you an error. So what if you want to find out the status of the thread? So you could do that with t1.thread state. And thread state again is an enum of type thread state. So let's look at the different possibilities here. At this time, when you create the thread at this point on line number 55, after you create the thread, at this point, the thread is unstarted. So line number 55, after line number 55, t1.thread state would be unstarted. When you run line number 60, right? When you run line number 60 and you start off running the thread, at this point of time, the thread state is running. So it's currently in the, in the process of running your thread. If you call line number 67, I'm doing a t1.abort. At this time, there are two things that are happening. First is when you call abort, it has a thread state of abort requested, but the thread has not yet been aborted. It might take a small amount of time for it to be aborted. And after it has been aborted, right, it then would have a thread state of aborted. Are we clear on this, everybody? After it has been aborted, it would have a thread state of aborted. Now, this aborted also, right? Aborted also is there for a short amount of time. And you have another thread state called stop requested and stopped. Now, stop requested would be if the thread has finished running, right? If it is finished running, then you're not explicitly asking it to stop. But there is a stop requested thread state for a short while. And then when it is actually finished, then the thread has stopped. So this is the exact opposite of whether it is running or not, whether the thread has stopped or not. Okay. After aborted also, after a short while after aborted, the thread state again changes to stopped. So aborted threads also are now considered as stopped. So there is, slight intervals of time, small intervals where the thread state would be that. Okay. You have two other thread states called suspended and suspend requested. Earlier, there used to be this code out here wherein you could actually do something like this. t1.suspend, right? And the suspend is like the pause. If you'd like to pause a thread in between, then you could call suspend. But the suspend has been deprecated. This was there in earlier versions of .NET. Now it doesn't do anything at all. Okay, so this is no longer valid code, but there used to be two statements that you could give. So this is no longer valid. This is after suspending it, you could resume the thread. And this also resume also doesn't work. This also is older code that doesn't work anymore. Okay. So version 1 and 2 of the framework had this, but no longer there, no longer supported. So anyway, coming back to this. So suspend. Again, if you are called line number 62, then there was a suspend requested. And then when it is actually suspended, then the thread state would be suspended. If you're trying to call resume, what should you first check out for? First check out for what? What can you resume?
Suspended.
That the thread state should be suspended. That code doesn't work anymore, but I'm just giving you an explanation of what that thread state is. Okay. We have tried out thread.sleep, not in this example, in previous examples where we were trying to make the code not do anything for a certain amount of time. So in the delegates example, we tried that out. Also today in the p-link example, I showed you that thread.sleep. So what does thread.sleep do? Thread.sleep says that the current thread should be put into a sleep mode for that amount of time, or don't do anything out there. Don't do anything. So for, let's say if I had said for 3 seconds, for 3 seconds, it does not continue running the thread. It just sort of waits out there. And if you've called thread.sleep, then the thread state at that time is a wait sleep join. Are we clear on this, everybody? Now there are other places also where this gets the wait sleep join, and we'll see one of the places where this happens. But one place where you already know where it will happen is in the thread.sleep. Okay. So these are the different priorities of a given thread, and then you could write code which checks for this. Okay. So read up on not priorities, thread states. Read up on thread states and read up on priority. I've explained them, but do some background reading on that as well. Okay, one last thing that I wanted to show you. What if this thread, right? You're writing some code on this thread, for example, and here you wanted some code that should only run after T1 is over. This code depends on the fact that T1 is over, and only then you want this code to run. What if you have a situation like this? What do you want to ensure now? What do you want to do before this line? What do you want to do before this line?
Complete.
Yes. You want to make sure that T1 should be over. T1 should be over at this point of time. Only then this code should run. Now, how do you make that happen? What you do is you call it T1.join. Right? Now, what would a T1.join do for you? T1.join would be a waiting call. Waiting for what? Waiting for what? Yes?
T1 to be over.
Waiting for T1 to complete. And only after T1 completes, I will write this out. Okay. I'll do this out here. Now, Again, let me make T1 run a lot of times. So T1 will run how many times? No, 5,000 times. Earlier you saw that it was not waiting for anything. It was completing the code in main, correct or no? It was going ahead with all the code. But now with the T1.join, this is where it's waiting for T1 to finish. So you can be sure that this code will run only after T1 is over. Let's run this. T1 ran a lot of times, but only after T1 is over, this code would run then. Are we clear on this, everybody? If I had not given T1.join, what would happen? Supposing I had not given T1.join, then what will happen? Where would this code run? It won't wait here. What will happen? After it will keep completing all the other lines of code, won't wait for it to. So this is a waiting call. All right.
So,
Yes.
so what if we give T1 dot is background and also T1.join, then what will happen?
It'll wait. It'll wait. It'll wait. T1.join is a waiting call. So internally, now that's a very good question you ask. Internally, for foreground threads, right at the end of the code, they insert code which says thread.join. The logic that they will use is what? At the end of the code, they'll anyway put a thread.join. So waiting for that thread to complete. And that's how a foreground thread waits and a background thread does not. Good question. All right. Now I mentioned that you don't have suspend and resume anymore, right? So there's an alternative that you can use, right? The alternative you can use something called as the wait handle. And every wait handle, this has two methods out here. One is a wait one, and one is a set. So wait one is like your suspend. It says that wait for it to be reset again or to be set again. And after you suspend it, now you can actually set it again. Now I can't do the code in here. I can't do the code in here because it's not that I don't have a UI out here now. But if I had a UI, I could have had two buttons. One button which would do what? One button which would do the suspend, and one button which does the resume. Now, instead of suspend, of course, you're using this wait handle, and then instead of resume, you're using this. So be aware of it, but I'm not showing you code to run this. If you are smart enough to write your own code, you can do that here. Like if some condition is reached, then you suspend a thread. And if some other condition is reached in your code, then you resume that thread. So that also you can try doing. Okay. So this code is actually, otherwise my code is similar. But in main and main one, this main one of the code that I copied, this is the only additional code that I had there, which is different from the earlier one. All right. So we've just seen few of the things that we can do while creating a thread. When you created a thread, what did we use out here? What delegate did we use?
Thread start.
Signature of thread start. What is the signature of thread start?
Function as parameter and with void return type.
And what parameters? What are the parameters to this function? Parameters are no parameters and return type is also void.
Void.
Okay. Now there's an alternative option available out here. So instead of using thread start, you have something called parameterized thread start. So this the parameterized thread start, and as the name suggests, parameterized thread start. Okay, this is used for calling a function which takes an object as a parameter. Okay, so look what I've done out here. Instead of using thread start, what am I using? Parameterized thread start. If you look at the signature of parameterized thread start, return type is still void. Returns type is still void, and parameter is of type object. So look at this here. You're actually receiving an object. Same way here, I could have directly said func2. Func2 is doing what? Receiving an object. So this is creating the thread and pointing to it. But where does the thread actually get started? Where do you actually call the function? Which line? This line is not calling the function. Which line calls the function?
T1 dot start.
T1 dot start.
111.
When you call T1 dot start, start has an overload which takes a object as a parameter. So whatever object I wanted to pass can be passed out here. In this case, I'm passing two strings, O1 and O2. Right? And all that I'm doing here is displaying the value in that function. Are we clear on this, everyone? Let's try running this and seeing the output. What am I passing here? O1 and O2, and that's what's going to be shown out here. I've purposely kept a smaller loop to show you what's happening. Right? So that is the O1 and that was O2. Clear? Other things that we saw in the earlier thread, those would be the same as before. All right. This receives an object. So what can it receive actually? I've passed the string here, but what can it receive? If it's object, what can it receive? Yes?
Anything.
Anything. So it could receive a string, an integer. If I want to, for example, create an employee object, I could even do this. Employee obj is equal to typecast that O to employee. If I'm receiving it as a employee object. All right. So whatever I want, I can pass it. But once you receive it here, you need to then typecast it to whatever values you had. If you notice the signature, it takes only one parameter. What if I wanted to call a function that had two parameters? I can't do that. Parameterized thread start says what? That you can only call a function which takes an object as a parameter. So I cannot use parameterized thread start to point to a function that takes anything other than the object as a parameter. But what if I wanted to pass two values to my thread? Then how could you suggest, what could you suggest to make it work? I want to pass two values to my thread. Yes, different ways in which you can do this. What could you do? I want to pass, let's say, an integer and a string.
So we can create a class which has two variables.
Very good. Very good. You could create a class or a struct. Either way, right? Struct would be faster than the class, which has two properties, whatever int and string that you want, and pass those values there. That is one way of doing it. Very good answer. Any other options? Anyone else has any other suggestions? Anonymous object, there's no concept called anonymous object. You can create an anonymous class and then have an object of that class, but you cannot pass that as a parameter to a function. So that is out. Any other?
So array, list, anything.
You could have used an array list, one possibility. Anything that take objects or an array of objects.
Yes, that's what I wanted to say, but then it mixed up.
Right? So array list, array of objects, you can pass that also. Anything else? Anything else that you can do? So I've got 2 right answers so far. Any other option? Think out of the box. I want in my
anonymous
function
class.
Anonymous
Class, as in like how we.
I want this one to access something that is here.
Anonymous method.
Correct. Anonymous method or local functions. Both of them will work. All right. So now you're seeing where all these anonymous methods and all of these are coming in pretty useful. So far, I mean, earlier when we saw them, you were all like, okay, it's there, but then why would I need it? So all these situations where you want to access some value in the function, which is written in the main function. How do you access that value? Local functions, anonymous functions. Okay, all of that can be done. So anyway, I put the to do out here. So to do, pass to values to the function, and giving you a hint as well, which says that was the first answer that came out, in fact. Okay. Create a class or a struct which has those 2 properties and pass an object to the class or struct to here, to that function. So to do, this is something for you to try out. Okay. Try it out different ways, different possibilities. All right. Okay, we're going to next look at the concept of a thread pool. Okay. So when you talk about a pool of resources, would someone like to explain to me what is a pool of resources? What do you understand by an object pool or a pool of resources?
Creating common resources for all to share them.
Very well said. Very well said. Correct answer. All right. Very nicely, shortly and sweetly explained. You were like a lambda there. Okay. Okay. So let me explain it in a little more verbose way and giving you an example of this. Basically, when you create a pool, it's something that is not available to only one person, but is available to everybody. Now, I'll give you an example. Let's say, if you join a company, let's say, you are in a couple of months, all of you all hopefully are going to be placed well and, doing the job that you want to do. And then, of course, after a couple of months after that, you're going to come and give me a treat and whatnot. So all of that is going to happen in a few months. Right now, of course, let's focus on what is the process before that. So let's assume you're working for a company and, the company has a company bus for dropping you home. But let's say you are required to wait back. So beyond the office hours, you're required to wait back. And a lot of these companies are in far-fetched, IT parks and whatnot, which there is transport is not easily available and whatnot. So a lot of these companies have a drop facility. So if an employee waits back at work, then he can, sign up for being dropped. Now there are two ways in which they could do this. One possibility is the person who is, needs to be dropped home. He can call for a Uber or a Ola or whatever, and he can, or a cab service, and he can go home to his house. That is one possibility. Now, when you're doing this, there will be an overhead of calling that Uber or the Ola and waiting for that cab to come to your location. So it is not readily available to you. Okay. So consider another situation. The company knows that a lot of people wait back late. So they keep a pool of cars readily available for people to be dropped back home. Okay. Now, what is the advantage in keeping this pool of cars ready? Keeping, a set of cars readily available for anybody who walks down and is available. What is the major advantage there compared to the other option of calling a cab?
You don't have to wait.
Waiting time is drastically reduced. You don't have to wait for that. Right? So you step out of office and the car is available. And that car drops you home and comes back again. Now, let's assume you're doing this every day. You're waiting back after work every day. Your project requires you to wait back after work. The next day when you come down and you step down from the office, would you get the same car that you got yesterday to drop you back home? Is there a guarantee that you'll get the same car? Or could it be different? Yes.
Different, sir.
Because you don't know what is the order now. If let's say there are 20 cars, whichever car is available at that point, you'd be given that card out. So you don't have a lot of control over that car. The advantage that you get is what? Advantage is it's faster. But the downside is you don't have a lot of control over which car you're using. You're using the first available car that's given to you. Okay. Now, when you work with any pool, there is this concept of a minimum pool size and a maximum pool size. The minimum pool size would be how many of those resources should always be available, should always definitely be there. That is the minimum number. So there's a minimum pool size. And similarly, there'll be a concept of a max pool size, when you can't go beyond that. That is the maximum number that you have. And there's also something which is the available things out there. So let's assume all cars are waiting in the garage, all right, or in the parking area. But 5 cars are kept readily available. So what are that 5 cars being kept readily available there? That is the minimum pool size. At any time, if 5 employees come, they should get a car out there. And there are other cars also available. But where are they waiting? They're waiting in the parking area. Now, what is the max pool size? Max pool size. Maximum number of cars that are there. They're not endless supply of cars, right? So let's say the company has hired 25 cars to do this picking up and drop thing out there every day. So that 25 cars would be the max pool size. Are we clear on this, everybody? All right. Also, when you're talking about pooling, imagine what will happen if 5 of you all come down at the same time. Right? Now, who gets the car first? Who gets the car first? What do? You run for it, like, sprint for the car and slide in under the car door and get in the car, or slide through the car window, like Jackie Chan, and get into the car, and that's how you get the car first. Is that what you do, or would there be a better system? What could be the better system? Yes. 5 of 12 have come. Who will get the car first? Who will get the car first? So here is where, yeah, go ahead. Somebody wants to answer.
By setting priority.
No, no priorities here. Here is where you have the concept of a queue. So what you have to do is you have to come and write your name saying that, okay, I want a car, I want a car, I want a car. All right. The company is randomly, I want to go out this room. They're not going to say, okay, take any car, what you feel like. No, that's not what. You have to tell them that, okay, this is the reason why I waited back. This is the project I'm working on. This is where I need to be dropped and I need a car. So you're actually filling in all those details. And this is the time that I want maybe the car to be approximate time I want it to be available and so on and so forth. So you fill in all the details and there is a queue. So whenever using a pool, there is a queue of, who gets to use that resource first. And if, for example, if there were only 4 cars available, but 5 people came down, then the first 4 would be given allocated that. And the 5th one has to wait until what? Wait until what? One of the cars
Not returning.
is available. One of them maybe has dropped and come back or comes up from the parking, wherever. If he's waiting the parking, it comes back, comes up out there. So he has to wait for that. So these are all these concepts that we have talked about. I've been talking about a car pool, but all of these are applicable to a thread pool as well. So the CLR maintains a certain number of threads that are readily available. So you don't need to create your own thread. You don't need to create your own thread. You won't be doing this. Instead, we'll be using a thread from the thread pool. And when you use a thread from the thread pool, the advantage that you gain is that you get it's faster, right? Rather than creating your own thread. It's faster. The thread is already available to you. But the downside is that you don't have a lot of control over it. So somebody mentioned priority, for example. I can't set a priority for that. All right. I can't prioritize myself. So you don't get the control that you would get by creating your own thread, but you get speed. The delegates that you created in the code the other day, when you said delegate.begin invoke, did we create our own thread out there?
No, sir.
So those delegates also were using threads from the thread pool. Internally, they were using threads from the thread pool. Are we getting this, everybody? So, somebody right at the start, made a statement that, oh, in delegates code, we created our own threads. So I corrected him immediately and I said, I'll, explain that later. Hopefully that statement is now clearer. I don't remember now who said it. Somebody said it and I said, no, we're not creating our own thread, and I'll explain later what it is. So this is what I meant by that. All right. So let's try out a thread pool. Let's try out code with the thread pool. I've created a function, pool function 1, a function, pool function 2. What is this function simply doing? What is this function simply doing? Same code as before, just printing out the values. But the difference is, I'm going to call it from the thread pool. So there's a class, inbuilt class called thread pool. See what it takes as a parameter. What does it take as a parameter? What does it take? Yes.
Wait callback.
Wait callback. All of these are questions that I am going to ask you in the MCQ. I am not joking. I'm telling you right now what I'm going to ask you. Thread start, parameterize thread start, wait callback. What is the significance of this? Where would you use what? So be aware of these things. All right. So wait callback. Look at the signature for wait callback. What does it take as a parameter? What does it take as a parameter? Object. And return type is
Void.
void. So what is wait callback like? Similar to which other one that have you seen which has the same signature? Parameterized thread start.
Thread start.
Parameter.
Parameterized thread start also had a similar signature out here. So I can use wait callback to call functions that have this signature, return type void and parameter of type object. Now, while calling wait callback, while calling queueUser work item, there's an overload to this. What am I doing out here in the second case? What am I doing here? What am I passing here? I'm passing some data to it. So when I call pool function 1, I am passing AAA to it. AAA is received here. When I'm calling pool function 2, I am not passing any value to it. So in the second case, I'm passing a null value to that object. In the first case, I am passing to it. So this is like, passing a null to this object. Now, why queueUser work item? Thread pool.queueUser work item. Why queue it? Why queue it? Why queue it? Why do you have to add to the queue of the thread pool?
For resolving that issue.
Correct. So that when multiple functions need to be called, whichever function has been added to the queue first would be given the thread first. So which is why this is the method that you're calling. Are we clear on this, everybody? As simple as that. So I've shown you how to call it with a parameter and without a parameter. Can I write pool function 2 directly? Can I write instead of saying new delegate and this? So that's what you could do out here. That's what I've done in this example. So this is the main function. All right. Now thread pool has certain methods called set min threads or get min threads. What do you think set min threads would do? What do you think set min threads would do?
Minimum pool size.
What should be the minimum pool size? What is get min threads? What is get min threads?
Number of threads we have set as minimum.
Correct. Similarly, set max threads. And there also, I have not written that down, but there also will be a get max threads. Are we clear on this, everybody? All right. Get available threads. Look at what get available threads does. What do you think this would be?
Number
All
of
threads.
cars waiting.
Number of threads that are readily available for you. Right? Number of cars waiting. Okay. Now you have two types of threads out here. Worker threads and IO threads. Okay. So both of these are used for different purposes. The IO threads are the ones that you're using in your code. The worker threads are used internally by Windows. So you don't need to worry about those worker threads or this thing. But IO threads are the ones that you're using. So this is to do with, the thread pool of how you can find out how many threads are there and then change this value if required. But it's suggested that you don't change this value. Let the CLR make changes to it. if you know what you're doing, then you change the value. Then it makes sense to change the value. Are we clear on this? This is your queue user work item. I'm just calling that function out here. All right. That brings us to one more aspect of threading that we're going to talk about, which is synchronization. Now, when you're talking about synchronization of a thread, essentially what you're talking about is if the thread is trying to access a resource that is also being accessed by another thread, then how do you resolve this? If there are two people wanting to access the same value or same resource, then how do you ensure that you can synchronize things between the two? Now, to explain this concept, I'll give you a simple example. Let's say there was in class 1, let's say, there's a static variable. All right, there's a variable here, static variable. One copy of that. Okay, let's say there are two functions which are both accessing that variable. Two functions which are both accessing that variable. So somewhere in there, okay, let's assume the value of this was 100. Okay, somewhere in there, you're doing I++, and let's say int j is equal to I. Let's say you're doing this. What value should j get? In your code, what value should it get?
100. Sorry, 101.
101? Yeah. Okay. Let's assume I had some other code written in function 2, wherein I said I equal to 200 int k and k is equal to I. I have done this in here. Okay. What value should it get? What is the expected value in k? What should k get now?
200.
200. All right. Now let's assume that both these functions are being run on separate threads and they're running at the same time. Okay. So let's say function 2 was running. Let's say function 2 was running. And function 2 did this, I is equal to 200. Not k, sorry, int k. It did I is equal to 200. It declared that variable. And at this time, a time slice occurred. Okay, at this time, a time slice occurred. So time slice meaning what am I saying when I'm saying a time slice occurred? CPU, let's say, was running two functions at one time. The CLR says, okay, you know what? At this point now, I'm going to give the other guy a chance to run. Okay. And this code comes in here. What is the value of I now? What is the value of I now in this code?
200.
201.
and j gets the value of 201. I has now changed to 201. So this function finishes, and this function knows, okay, I don't care about this function. But now it comes back into this code, and it's now starts running this code again. Now, what is the value that you wanted actually in K? What did your code want to do? You wanted 200. But what are you going to get now? 201. Reason being because in between your code, some other code has run, which has gone and changed this value of this shared resource. And this can be anything. The shared resource need not be only a variable. It could be a database, it could be a file, it could be anything. If somebody else goes and changes the value, then your code, suffers. So whenever you're working with threads, this issue is likely to happen. When you've got a shared resource and two functions are trying to access that same resource, one function might change something while the other function is running, and the other function might get unexpected results. All right. So how do you avoid this? What do you do to avoid this? There are certain synchronization techniques given here. We'll use some of these. The first possibility is you can, in C#, you can use the lock statement, and the lock statement looks something like this. I'll show you what I'm doing out here. You can use the lock statement. Okay. Now the lock statement uses an object. So this object that it's using, it's called this key. It's called as a key. And this object can be any object. Okay, this object can be any object. So I'm using this object as a key. Now the concept is very simple. Supposing there is one room. Supposing there's one room, which two of you all are using to go and maybe whatever, keep your things out there in that room. Now you want some privacy. That while one person is keeping this, the other one should not enter that room. Okay. So what do? You have a key to the room. Whoever has the key can now use the room. While he is using that room is locked effectively for the other person. Other person now does not have access to that. Are you getting this, everyone? So whoever has access now will be giving this. Now when he's finished that, what does he do? He keeps the key back. He says, okay, now I have finished using the room for whatever I want to. I've kept the key back. And then the other person can come and then take the key after that. So this statement works in a similar way. Now, when you say, I'm doing this in two different functions. When you say lock obj, and you're given this, see, there's a block, there's a code block here. There's a code block here. Similarly, lock obj, there's a code block here. It begins here and ends here. So while you're in the middle of that code, if a time slice occurs, then the CLR goes and tries to call this code. If there is a lock statement, it will not enter this code until this lock has been freed. Until this other lock has been freed. So where is this other lock getting freed? At the end of this code block. So even though time slice has occurred here, and the CLR has now told this one, okay, please go and run your code. This one says, okay, sorry, this OBJ is now being locked. It's gone into that code out here. So since it's in the middle of that code and both of them are using the same object, they are using the same key. it will not enter this code block at all. It will not enter the first code block. So what will happen now? Control will come back to this one and it continues with the execution and it finishes this. So you have ensured that during this time, nobody else has gone and changed I. So your code will come out correct based on what it was doing. Clear on this, everybody? So that's how you can do synchronization with the lock statement. You simply lock it, release the lock at the end, and it takes care of it. Questions, if any? Locking easy? Okay. Now there is, if you look at the lock statement is only in C#. So C# gives you the syntax, like there is no lock statement in other .NET languages. Now, when you write the lock statement, internally, this statement is converted by the compiler to monitor.enter, and when you release the lock, this statement is converted into monitor.exit. So monitor is a class in threading that provides synchronization. Okay, with two methods, enter and exit. But instead of using the monitor class in C#, specifically in C#, what can you also use? What can you also use instead of monitor.enter or monitor.exit?
Lock.
The lock statement. But lock and monitor.enter exit are identical. They work in exactly the same way. Are we clear on this? So we'll try both. We'll try both these, but syntax is different, but statement is the same. All right. Now take another example. Okay. So if you write a statement like this, let's say j is equal to I++. This is broken down, right? Or let's just take it here this way. This is broken down by the IL, okay, into multiple statements. So I don't know IL, but the logic will be something like this: store I somewhere, or store I somewhere in memory, right? Get the value of I, add 1 to the into temporary area, let's say, add 1 to the temp, store 1 plus temp into I store original value of I into J. So something similar like this is what it will be doing. So this one line of code out here that you write actually has multiple lines in IL. Now, what if a time slice occurred in between these lines? A time slice occurred in between these lines, and it went and changed the value of some of the variables that you're using in your code. So this is only one line of code, but there is a possibility that that one line is split up into multiple operations, and a time slice occurs in between these operations. Am I making sense? Are we clear on this, everybody? So what would you do in this case? Now you can't put single line of code into lock. I mean, it'll be painful to do that. Imagine writing each line of code, writing it in a lock statement. Could we have locked it? Could we have put this all into a lock and ensure that nobody else gets control in between this? Could we do it? Can we do it? Answer is yes. But how many lines are you writing a lock for? This is writing a lock for one single line of code. So I don't want to do that. I don't want to write a lock for a single line of code. I can do that if I want to. I can write a lock for one line, but there are better options available. And that is where there is another class here called as interlocked. There's another class called interlocked. And interlocked has a lot of methods that you will use when you're performing common mathematical operations. So like, for example, I is equal to I plus 5, I is equal to 10, I is equal to whatever, j minus 3. These common operations that you perform to ensure that they are, synchronized, that you don't have to write a lock for that. You can use them with the interlock statement. And this interlocked is like writing a lock for one line of code. All right. So we'll see the usage of this in a short while. I'll show you the code. But typically standard mathematical operations would be performed out. Let's try this out. Let's, work with the synchronization in threading. So first thing is, let's take you back to the code that pseudocode that I wrote. What was I using out here? I was using a variable I, and I was using a lock object. That's precisely what I've done out here. I'm using a variable I, and I'm using a lock object. I'm starting, two functions. One of them is called func lock. The other one is called func monitor. Look at func lock. What have I done out here? Lock and the lock object. What is the lock object? Just the regular object that you are creating. Okay, now I have purposely sort of just written multiple lines just to show you that in between all this code, it's not going to go anywhere else. That's all that this code is doing. I've written a lot of lines of code to ensure what? That in between this code, there's no time slice going to happen, even if you run it separate, individually. So that's where my lock ends. And the same thing could have been done with what? Monitor.enter with the lock object. And similarly, at the end of this, you're doing what? Monitor.exit with the lock object. So this is what we're doing with either the lock statement or with monitor.enter or exit. Okay. Look at the other example. What are we doing in here? What is this doing? Using interlocked. So I've just shown you 3-4 methods here. Look at the first one, interlock.add. What do you think this interlock.add would be doing? This is like doing what? It's saying ref I, 10. Like doing what? Like doing I plus equal to 10. So that statement can be represented as interlock.add ref I, 10. What about this one? Interlock.increment ref I, similar to doing a plus I. Interlock.decrement similarly, minus I. And interlock.exchange ref I, 100 is like saying I is equal to 100. So wherever you're using shared resources, right? Like I was a shared resource. Wherever you're using shared resources, and if your statements are single statements like these, then don't use these statements. Instead, use what statements? The interlock dot, one of the methods out here. So these are the synchronization methods that we have discussed out here. 3 possibilities: lock statement, monitor.enter, and third possibility was the interlocked example. All right, I'm not running this code. You can try this out in the lab. All right. Questions, if any?
So
Mm-hmm.
So how does the the object we are using to lock, how does it use it to lock the method
It's
or
just the
object?
identifier. Just an identifier.
Okay.
Supposing 2 methods are using the same object, and in one method it has finished half the code and then time slice has occurred, then any other method that is using that object, any other code that is using that object, it will not go into that code.
So, but how would we know that it is using or not? As in, if it might have been a Boolean value or a flag like thing, so we could have said, okay, the value of Boolean is true. That's why we can't go in that particular method.
It is using it as an ID. So you can think of it this way, that it will take the hash code of that, whatever the hash code of that object, it will just use that. So you're not writing code. You're not writing the if else. That if else is being generated by the CLR. The CLR is saying, okay, if this object is being used somewhere else, I will not give this guy a time slice. If you look at this code, what object am I using? I'm using lock object. So now let's say on line 225, a time slice occurred. Let's say the time slice occurred here. Right? Now, which functions am I running? I'm running func lock and func monitor. Both I'm running. So time slice occurred here on line number 226. And which other functional wait running? See, both threads have been started. So which other function is waiting here now? The func monitor is waiting. The func monitor is also using lock object. Supposing it was not using the lock object, it would have entered this code. It would have entered this code and it would have gone and executed this code and changed the value of I. So we would have had a problem. Now, because it is using the same lock object as was there earlier, this code will not run until that earlier code is finished. So you can be sure that that earlier code, which is in one, long code block, there will be no time slice, or even if a time slice occurred, it will not be giving access to this other function which uses the same lock object. All right. And like you said, if there's a Boolean variable or whatever, I would keep track of it or whatever. So that's the best part. I don't need to do that. This is being handled by the CLR. All that it's asking you is what? Give me one object. Give me the same object. That's all that it's asking. Hope that's clear.
Yes, sir.
All right. So try out these examples. I'm not, it's 1:50. I don't have enough time to start or even complete the other example that I have in even a little bit out there. So try this out. We're not done with asynchronous code. We're going to be looking at one more way of writing asynchronous code out here. So, but we'll do that in tomorrow's session. Okay. So stopping here for the day. Any last questions before I disconnect? All right. So just a reminder, please try out the code from linksamples.com. And, I've given you a few to-dos to do. So complete those to-dos, whatever needs to be done. All right. That's it for this session.